Greetings everyone. Today we're doing problem 28, implement strStr. This problem was given by Google in a coding interview, and last time I did it in C#. Today the JavaScript is the one that we're going to be taking a look at. So let's read the problem. Given two strings needle in a haystack, return the index of the first occurrence of needle in the haystack, or -1 if needle is not part of the haystack. We have a clarification question here. What should we return when needle is an empty string? This is a great question to ask during an interview. Now they are saying that this is a great question to ask because as a person who is writing the code in the coding interview, you always need to be sure that you know what is expected of you to return. Because if you have not understood the question, then you're going to spend 1 hour coding something irrelevant and you're going to look like an idiot. So it's always nice to ask clarification questions. Don't be afraid that you're going to look stupid, that you have not understood the problem. Sometimes, and some of the LeetCode problems, I am not able to solve right away because I just do not understand the question good enough. And there's no one around so I can go and ask, what do you mean, right? Because this is, all you see is all you get here. For this purpose, for the purpose of this problem, we will be returning 0 when the needle is an empty string. And we're going to do that because it's going to be consistent to C, C++, and Java. If you want to see how it's going to be implemented in C, you have a link here, and they're going to show you what's expected. But you have me, and I'm going to explain it for you, so you don't need to go to the link. Now, furthermore, we have a couple of examples here, and I'm going to go with haystack. Let me just go with my little drawing problem here. All right, I'm going to write hello. Sorry for my mouse, it's still a little bit ugly, but I haven't bought a pad yet. And the whole idea here is actually not that hard. Now, there are a couple of edge cases and a couple of optimizations that I have done, and I will be explaining them to you. And but first, I think that in order for you to understand, you need to understand the whole problem. So let's go and walk you through. Now, if I go to see if LL is a needle in the haystack hello, what I need to do is to stop when I have actually found the first character that the needle possesses, meaning that H is not going to be a valid candidate, E as well, and here L, you can actually see that it's equal to the needle's first character. Now that's great because from now on I can just start iterating both of them and just test if they are equal, and if they're equal, then it means that I have found the needle. Now the optimizations that I have been talking about is the following. Now I'm going to make them with green. So optimizations is the following. Now I do have a needle length, meaning that I do have 2 characters here. If I go to L, and since I have 1 character now, of course I can have a couple of L's here, so I can have a very big needle in the very large haystack. I am going to, for example, here have 1 byte, and I'm going to move this thing over here, this pointer, I'm going to move with the bytes that I have in the needle. So if the needle has a length of 5, I'm going to move this 5 times to the right, and then I'm going to check the following. Is the last character of the 5 bytes that I have moved equal to the last character of needle? If they're equal, then and only then I'm actually going to go and check this range here that I have. And then I'm going to keep a count. Now, if the count here is 5, so we have 5 equal characters to the needle, and the needle whole count is 5, it means that I have actually found the needle, right? But if the needle count is 6, and I have found only 5 matching colors, characters, it means that obviously the needle is nowhere to be found over there. So that's the optimization. Now, that's not a perfect thing because, as I said, it's just something to optimize. It's not something to fix the whole problem, because we can have, now, if I think something out, I can say L, L, O, L, and I can have only L's here. So I'm going to go to the first L, I'm going to meet the first L, and then I'm going to place 3 characters to the right, meaning here, and let's write this with green because this is the optimized thing. I'm going to check if this character is equal to this one, and they are, right? But then I need to check if all of the characters between these range are equal, because here you can see that I don't have the needle. It's something that looks like a needle, but it's not. And that's pretty much the caveat that I wanted to talk about. With that said, let's actually go and code it up. Now, for the first part is, of course, I want to check if needle.length is bigger than the haystack.length. And if that is the case, I'm just going to be returning -1. Now, I'm going to be returning -1 because if you think about it, if the needle is hello and the haystack is LL, there's no way that the needle can ever be found in the haystack because it's just larger. All right, with that said, now I need to say the starting pointer, the starting index of the haystack that we're going to be iterating. And that's, of course, going to be equal to 0 because we want to start from the beginning. Now I'm going to be talking about the optimizations. Oh, one more thing that I forgot to mention is, for example, if I have hello and I have a needle of long, I don't need to go all the way here, right, to check if these are equal to the needle, because they're not. Meaning that what I want is to have the range of the needle at least, meaning that I am going to stop at E, right? And I'm not going to check this L because the final characters are 3 and the needle is 4 characters long. So that's one more optimization that I forgot to mention. And I'm going to code it as needle and index. That's going to be equal to needle length -1. And index is the optimized thing that I have been talking about. This is going to be equal to our haystack length minus our needle and index. Once again, I'm just keeping this end index because I want to be sure that needle can be found in the haystack. And there's no, if the needle, for example, is 100 characters long, there's no need for me to keep going 100 times to loop through the loop and do the checks. All right, while starting index is less than end index, I'm going to code something up, and let me just bring this to the left so you can see a little bit. Yeah, I think that's actually good. 125% is good. Now, if needle, the first character of needle, and that's the way we're going to do it, is equal to the haystack of starting index, right? So this is what we're going to be iterating with. If the haystack of starting index is equal to the first character of needle, and also the optimized thing that I have been talking about, starting index plus needle and index is equal to needle of needle and index. Now I did that because, once again, if I have hello here and now L, I do want to make sure that this character over here, so that's what we did, this character over here, is equal to the final character of the needle. Right, good. Now, also the counter part, so I'm going to say counter is going to be equal to 1. Now I'm going to keep count of how many characters are actually equal. I'm going to start with 1 because I have already found something that is equal over here. And the final part is actually easy. For let current index, do I have something named like that? No. Current index is equal to 1, again, because we have already found the first matching color, character. I love to say color instead of character. Index, current index is less or equal than our needle and index. I'm saying less or equal here because needle and index is the length -1. That is going to be valid. And current index plus. All right, for the checks, I want to say if haystack of starting index plus the current index is not equal to needle of current index, I'm going to break. I'm going to break because it means that I have found something not good. Low, and I'm going to be searching for 3 L's. And here I'm going to say, all right, this one first is equal, good. Second one is equal, good. Third one, not equal, just break and say no needle found. Else I'm going to increment the counter. because we have found a matching character. And the final part for me to do is to say, did I found enough matching? And here, you know what, I'm going to say matching char, and are the matching chars equal to the needle length? If they are, I'm just going to return starting index, because once again, we are required to return an index somewhere here. Given two strings, needle, return the index of the first occurrence of needle. All right, and if I have not found anything, I am just going to go with -1. And I think that's actually good. So let's run it and see if I need to add. I think I didn't need to add it, but yeah, here you can see the needle length is actually always bigger or equal than 1. So I don't need to do this check of the clarification question that they have provided us with. All right, I have an infinite loop here, so I did mess up something. Of course, after everything, I am going to be required to say starting index ++. So let's check now, because otherwise we're not doing anything. Okay, good. So let's submit and see if that is going to work out. All right, well, that was the problem, guys. Thank you for watching. And if you have any questions, leave them down below. Bye.